And I think we're live. Yeah, we're live. Perfect. Okay, now that we are live and got a record of it, and my one student is here, I just have a quick announcement to make. We have our first assignment. Um, so assignment one. Assignment one. Where's my marker? Here it is. So announcement. Come on. Here we go. Announcement. Assignment one will be posted on Google Classroom by the end of this period. Okay, so ideally what I would like to do is just give each cluster a chance to have a class where we can take a look at the questions. So I guess it will be due on Wednesday at the end of the day. This will be due on Wednesday at the end of the day. Okay, so it's a fairly short assignment, just kind of checking in on our quadratic skills. But yeah, I think it's like 5 questions long or something like that, maybe 6. I don't remember off the top of my head, but it's a fairly short assignment. Just mostly because I don't want to have to mark a super long assignment. So yeah. Anyway, let's see here. Okay. All right. Okay. So let's begin then. Okay. So what I thought we could do is just try factoring some of these more complicated functions where we kind of need to do several steps. So we'll start off with a fairly straightforward one. Let's try something like this. So let's factor this one here. How about this one? This one is I'm just stealing this one from the book. I think it's on page 73 or 173, page 173. What is this? 3M. Number 3M. Okay. So this one is, what is it? 4a squared minus 7a plus 3. Okay. So what I'm going to do for this one, I think one of the most common questions that I've had so far is this issue of the rectangle model. Just going to put Discord on here, so if anyone has any questions, they can ask on Discord. So yeah, I've been having a few questions about the rectangle model. It may not be as intuitive as just doing it in algebra, but the nice thing about the rectangle model is that we can generalize it to other sort of models. For example, probably sometime next week or the following week, we may be doing something called completing the square, where using this rectangle or area model is going to come in handy. So we're going to do our best to make sure that we understand this model. So let's try this out. So I'm going to make myself a little rectangle here. I'm going to make it big enough that I can draw in it. So here is the other portions of the rectangle. Okay. So in the first part, I've got my my square part. So this is going to be 4a squared. And then here I've got my 3. Okay. So I need to figure out what all these different sides are, right? Once I've got these sides, then I think it'll be good. So I know that that one of these sides is going to be well, it's going to have some kind of blank times a, right? Not a squared. So some blank times a. This will be another blank times A, right? And then these sides are just going to be constants. So there's not going to be any kind of A in them. So we might have something like a star over here and maybe a circle. So I'm just coming up with different shapes for different numbers that could be there, right? So hoping that these are all whole number values, you can probably imagine that if this one was 3, then this side over here would be 1, or vice versa, right? So our goal here is actually just to try to find the lengths of each of these sides, okay? And one thing that I tried to emphasize before is that if we were just to kind of come up with a bit of a naming scheme for each of these sides, so if I were to call this side A, this side here B, and this side C, and this side D, well, one thing that we would know is that, well, I mean, it's not immediately obvious why we would do this, but it does make sense when we actually are looking for the certain numbers. So if I took A times C, which is this rectangle here, is A times C. So if I wrote A times C, and if I were to multiply it by this side right here, this side right here, if I were to multiply B times D, which is what this rectangle is, if I multiplied that by B times D, well, that's going to give me, well, that's this rectangle multiplied by this rectangle. So A times C times B times D, or just all of those sides multiplied with each other, that's going to give me, well, 12A squared, right? Because that's in other words, well, A times C is 4A squared, B times D is 3, and that's where the 12A squared comes from. So maybe I'll rewrite that. So it looks something like this. There we go. So the other thing that we know is that, well, we're kind of missing something here. So what we don't know is what goes here and what goes here. But I know that when I add them together, I'm going to get negative 7a, right? So our goal is to say, okay, well, some of our negative 7a is going to go here, and then another 7a is going to go over there, okay? So that's what we need to figure out is how do we distribute this negative 7a throughout these two rectangles. So that's really what we're doing when we're factoring a quadratic. So let's go ahead and see if we can sort of come up with some kind of system to express what's going on here. So in other words, this rectangle, which I know has one side which is D and one side which is A, so A times D, so A times D, A times D plus B times C, which is this side, B times C, is going to be equal to, well, whatever that's equal to, it's going to be negative 7a. Negative 7a. Negative 7a. Okay? And here's the thing. This is just all the numbers multiplied by each other, right? Those are the numbers that are multiplied by each other. So what I'm going to do, I'm going to just rearrange these a little bit. So I've got A times D times B times C now. Same thing. It's just a big product, bunch of numbers multiplied with each other. And if I multiply them together like this, if I think of them as two numbers multiplied by each other, maybe I'll just write it like this. A times D times B times C. Well, that's what my 12a is, right? That's what my 12a is. I'm actually going to put this back up here. I think we understand where the 12a comes from. Okay, so here's the gist of it. Here's the gist of it. I know that if I multiply all these numbers together, I get 12a, and if I take A times D, which is this portion, and I add it to B times C, that portion, I get negative 7a. So our goal is to figure out what these numbers are, what these little areas are. So AD is one of our terms, our terms. This is the other term. And we know that when I multiply those terms together, I get 12a. Or in other words, I get this number times this number. Okay? So that's where this is all coming from. That's why this works. Okay? I should make sure this is open. Okay. So what we want is we want two numbers. Two numbers we want are going to go here and here. Okay, this is just kind of like, this is almost like long division or something here. What we're doing, this process is kind of like some kind of algorithm that just helps us sort of find certain numbers. So I like to put the multiplication symbol there and the addition symbol there. Okay, when I do that, what I'm looking for, one of these sides I'm looking for AB, the other side I'm looking for BC. So I know that when I add these two numbers together, I'm going to get negative 7a. And when I multiply these numbers together, I'm going to get 12a squared. So I can put a 12a squared up top here and a negative 7a down here. So I'm looking for a pair of numbers whose product is 12a squared and whose sum is negative 7a. So all that really remains to be done is to say, okay, well, I'm thinking. Do you have any suggestions, by the way, about what those numbers are? Okay, yeah, that's all right. So if we wanted to find those two numbers, what I would start off with is I would start factoring 12a squared. Okay, I know that I'm gonna need an a on both sides. I'm gonna need an a on both sides because I multiply them together and I need to get a squared. But then if I add them together, I still need that a there. So I'm gonna get a on both of them. And then I look at the factors of 12 now. 12 is positive, but the sum is negative, which means that both of those terms should be negative, right? So I'm thinking negative 3 and negative 4, right? Because those are factors of 12, right? And when I Yeah, there you go. There you go. Great. So now we know what goes in here. We've got a negative 3a, and negative 4a. And the beauty of this model is that it doesn't matter which one goes where. You could put it wherever you want. You could switch it up. Doesn't matter. I could look at this. I'll change it. 4, 3. Doesn't matter. It's because there's some symmetry here, right? This is kind of a symmetric diagram. And nothing is to scale. So we don't have to worry about filling in the right number in the right place. So nothing is to scale. So let's have a look here. Now what our goal is to find out what all these values are. Right? This A, B, C, and D business. So what are these values? Well, what we're going to do is we're going to sort of go through here. We're going to say what's the biggest factor that we can take out of these two terms, and that's what C is going to be. C is going to be that biggest factor. Can you think of anything that we can factor out from both of these? Yeah, we can factor out an A. So let's call this. Let me just choose a different color. How about orange? So yeah, this is going to be A. Yeah, that's the biggest thing we can take out of that. Now, look what we just did. I know now that this is A. That tells me now what this must be because I know that the area is 4a squared, right? So what is this side going to be? 4, because A times 4 is 4a. Yeah, exactly. So this is going to be 4a. Because 4a times a is 4a squared. That's right. Okay. So now I know a little bit more about that. Okay, now look what I did. Now that I found 4a, and I know that the area of this is negative 4a, do I know what this is? What this is now? Yeah, it's got to be negative 1. Okay. And I guess I should be putting the 4a up here. Okay. And then now that we know that this is negative 1, and that this is 3, what do we think this side is going to be? -3, yeah. And we're done. So the way this is worked out is that we've got, well, this is the area, right? And we are just expressing this area in terms of length times width, right? So our length is 4a minus 3, and our width is, well, a minus 1. A minus 1. So there's that area model, or the rectangle model. Just full disclosure, one of the questions on your assignment is to use the rectangle model. So I am going to ask that you do use this model. Keeping in mind, however, I don't want you to use this model every single time you factor a quadratic. That doesn't make any sense at all. This is just a model to help your understanding. This little trick, however, I think that this is a great little trick. This I think sometimes it's called the diamond trick. I think it's great. I think it's a great little trick. But some people actually just prefer to do this in their head, and that's fine too. You're perfectly capable of doing that in your head. There aren't that many numbers that you have to hold, like in your prefrontal cortex or whatever you want to call it. Like it's at the end of the day, it's 4 numbers that you have to be sort of juggling with. Something like long division has, like, sometimes there's 7 or 8 or a lot of numbers, right? So you can't really do that in your head. This is just 4 numbers. And also when you start doing more of these, you can kind of ignore the A's, right? Because you already know instinctively what the variables are going to be, right? Yeah, exactly. So it's really just like 4 integers, not too bad. So a lot of people can do this in their head, but I still find that it helps. So yeah, I wanted to do this same example really quickly without using the rectangle model, but I just kind of want to show you where some of these numbers are going to reappear. So I mean, the main thing that we did was that we found these 2 numbers. This is the crux of the problem, is finding those 2 numbers. Okay, that's the crux of the problem. In the rectangle model, or the area model, what that translates to is, here's our -7a, and we're distributing 3 of those a's over here, and -3 of those a's over here, and -4 of those a's over here, right? And then we just looked at the diagram and factored it. When you don't use the diagram, it's almost exactly the same thing. Okay, so what was it? 4a squared minus 7a plus 12. You do almost the same thing, except you turn this -7a into -3a minus 4a, like that. Okay, so you're pretty much just doing the same thing again, right? Like it's 4a squared minus 3a minus 4a plus 3, right? Oh, this should be plus 3, my bad. Plus 3 plus 3. Okay, so it's pretty much the same thing. You're just writing it algebraically now, and then you're kind of doing the same thing that we did before. I'll try to do it actually in the same order. So maybe actually, instead of writing it like that, I'll put the 4 first. Yeah, 4, because the order doesn't matter. So we're pretty much doing the same thing here. What we do is we take a look at this side here. Yeah, we started off looking at this, the 4a squared and the -4a, which is this. So if we were to factor that out, well, I get the 4, and then I'm left, or so the 4a, and what I'm left with is a minus 1, right? So that gave us, that's where we came up with the 4a, and that gave us the a and the -1, right? And then we do the same thing again over here. We factor out this, and this time we factor out a, we'll factor out a -3, and then we'll be left with a minus 1. So basically what we're saying is that we say, okay, well, we've got an a minus 1 over here. We're just doing it in a different order when we do it algebraically, but geometrically it all adds up. So here's my a minus 1, and then here's another a minus 1, right? So we've got a minus 1, another a minus 1. This sort of a minus 1 is a minus 1 times 4a. This a minus 1 is a minus 1 times negative 3. So there's my 4a, and there's my negative 3. So really what we're doing is we're saying, okay, we got a bunch of those a minus 1s. Let's factor that out. I'm going to factor out an a minus 1. And what I'm left with is a 4a minus 3. Okay? So here's kind of where I'll try to color code it. So here's my a minus 1, a minus 1. So the a minus 1s get factored out. And then I get a 4a, which is over there, of course. And then a minus 3 is over there. So yeah, that's the gist of it. Okay. So okay, how long has this video been? I'm trying to keep it nice and short. Let's see. Okay, so it's 20 minutes. So I'm gonna try to end it pretty soon. I kind of just want to give you a bit of a hint as to kind of what we're doing. So I'm gonna turn this function into a function of x. Okay, so I'm gonna turn this into a function. Okay, so I'm gonna turn this into a function. I'm gonna say that this function is now gonna be a function of x. So this is going to be the function 4x squared minus 7x plus 3. So it's the same quadratic. I just changed the variable and I set it equal to a function, right? Let's have a look at what this function is going to look like. And these types of functions, we are going to spend a lot of time with this year. So the function is 4x. Oops. So I'll write f of x equals 4x squared minus 7x plus 3. Okay. So let's take a look at what's going on with this function here. So it's a little bit different than some of the functions that we looked at last year. Like last year, all of the functions that we looked at were linear, right? So they looked something like y equals 1/2 x plus 3, you know, that kind of thing. They all kind of were those straight lines, which are cool, but I think we kind of exhausted everything that we could learn about them, right? This one, there's a lot going on, right? So this one, it looks as though it actually crosses the x-axis more than once, right? It goes down, crosses the x-axis, and then goes back up again, right? So we kind of have this sort of relationship. So those are the two x-intercepts there. So this actually has two x-intercepts, okay? So those two x-intercepts, the two x-intercepts of this function, so that these two, we'll say the two x-intercepts of this function are, well, according to Desmos, 0.75, 0 and 1, 0. Do you think you could have figured that out without graphing it? Well, let's see what happens when f of x equals 0. Okay, when f of x equals 0, well, this is what my f of x is, right? So if 4x squared minus 7x plus 3 is equal to 0, well, let's see what happens. Well, hold up, let's use what we just learned. And I know it might be a little confusing because we were using a's for a little while. Now all of a sudden I just changed variables and I'm calling it x. I'm just trying to convert this into a function that we can use. So let's use that format. That is the factored form of this function. So this would be x minus 1 times 4x minus 3, and that's supposed to be equal to 0. Well, yesterday we learned that if there's a product that's equal to 0, one of the factors must be equal to 0. So this must mean that either x minus 1 is equal to 0 or 4x minus 3 is equal to 0. Let's solve for those. Well, for one of them is x equals 1, and the other one is, well, I'll say 4x equals 3, and then divide both sides by 4, and then x is equal to 3/4 or 0.75. I wonder if we recognize those now. So there's one. Here's another. So this is just a little preview as to kind of where this is all going. Okay. So if this doesn't make like perfect sense immediately, don't worry about it. It will. But this is kind of some of our motivation. Okay. So we started off learning how to factor these quadratic expressions. Then all of a sudden we had quadratic equations, right? Now we're jumping we're going head first into quadratic functions, okay? And these functions, there's a lot to say about these functions and how we graph them and what their graph looks like and all that fun stuff. So this is kind of where we're headed. I thought I would just give you like a bit of a, almost like a courtesy sort of thing. Like, okay, yeah, this is what you can expect going forward. So this is kind of what functions eventually look like in the future. So yeah, we're gonna leave it there. Unless anyone on Discord has any questions, but I haven't heard anyone. I think a few people asked if they could ask questions, but I don't think so. So the extra homework that I'm gonna throw on you now. Let's see here. Let's try this question here. Yeah, I'd like you to try question 8 on page 176. Oops. Question 8 on page 176. Okay, and we'll do half of them. Half. Okay, so don't feel like you need to do all 6. We'll just do 3 of them. So just 3 questions, but they're not easy questions. They're pretty tough. But I also don't want to make you so busy that you don't have enough time to work on the assignment. So remember that the assignment is due on, what did I say, Wednesday? Where was it? Yeah, Wednesday. Yeah, Wednesday at the end of the day. So yeah, we want to keep that in mind. Do you have any questions? No? Okay. So I'm going to end the video there then. If I can find that tab. There it is. Okay, bye-bye.